Okay, for maybe those of us who don't know or who forget how to use a table of values, how do I do this? I have here a relation, or maybe a function, y equals, gentlemen, x plus 5. How do I fill in this y column here, Ben?
You just y equals whatever you add to the x, so negative 2 plus 5.
Y equals negative 2 plus 5. And what do you get for that?
Negative 3.
So you're going to use this substitution. So whatever x is in this column, negative 1, 0, 1, 2. Oh, my bad. Negative 1, I replace this x here with these values, so I get lots of ordered pairs. Can someone tell me what would you have in this first table of values when I plug in the next number? Austin? 4, 5, 6, and 7. How many of you were able to get that? Okay, what about the next one? This one's a little bit more complex. What math do I have to do here? Jenny? So 2 times negative 2 minus 2. And what do I get for that? Negative 6. And then what do I get for negative 1? Austin? Negative 4. Continue. Very good. We're going to be using table of values today. I don't need to see this step here. You can just plug it right into your calculator to do that. I'm not so worried about seeing this part here. I'm assuming that everyone knows how to do that. So our learning goal for today, we're going to be talking about parabolas, which all of you were exposed to in grade 10. We're going to review this. We're going to review this. So again, this shouldn't be too new. I hope it's not too new. Today we're looking at just vertical transformations of the basic parabola. And we're going to discover or refresh our memories by using a table of values. You're welcome. No. Okay, I have this first picture on here of a parabola. Parabola is that U-shaped shape. And there's a couple of properties that we have to talk about when we are working with the parabola. Okay, first of all, the vertex is this point right here, and I'm going to be asking you always what the vertex is. The vertex is the point where the turn occurs. Okay, and you're always going to write your vertex as an x, f at x, or xy coordinate. This line here that splits it in half, so it's a mirror. So it's symmetrical. This line here, we call that the axis of symmetry, and you're going to decide that axis of symmetry, or you're going to tell me that axis of symmetry, and it will always be in an equation x equals some number. And we're going to talk about that number. Austin? We have y-intercepts, x-intercepts. The optimal value, is going to be either a maximum or minimum, and it will always be written as y equals something, whatever that something is. And we'll be able to tell what that something is when we have actual numbers on our Cartesian plane. So this is, again, it shouldn't be new. The vertex shouldn't be new. Maybe some of the notation will be new. We'll see how that goes. So we're going to talk about the basic parabola. So it says here, transformations are operations performed on functions to change the position or shape of the curve. To see how a transform affects the curve, we must first have something to compare it with. We use this basic function as our comparison graph. F of x equals x squared. So this is our basic, this is our parent function. This is the one we are always comparing it to. So I have to figure this out. We are always going to use these x values in your homework. You are going to be plotting this graph a bazillion times so you can see the comparisons. So I want you to fill out this table of values right now. So I have here x is equal to -2. I want you to find when f at x, find f at x, which is just saying I take f at -2 and I substitute -2 in. Take 2 minutes and I want you to do that right now for me. If you need a calculator, please come up and get one. Ben, do you need a calculator?
Yeah, sure.
Zach, is there a problem?
No.
Can you, again, you're not going to do anything? Don't bother coming to class. If you're here, these notes are helpful to you, please do them. Okay, what do I get when x equals 2? What's f at -2? What do I get for that? Zach? Good? F at -1, what do I get for that? Robbie? F at 0, what do I get? F at 1? F at 2? Okay. Now I want you to plot this. So when I plot this, this is an ordered pair. So this is saying, this is how you would write it, -2, 4, but it's in a table of values. So when I have -2, I go left 2, up 4. 1, 2, 3, 4. -1, 1. 0, 0, 1, 1, 2, 4. And it's a curve. I'm putting arrows up at the top because it is continuous. I could have picked x is -3, x is +3, but those are typically the 5 points that we're going to be using. Okay, then this next piece, information, it's how do you describe this? The direction of opening, how does this open? It opens up. What's my vertex here? Where does my vertex occur? Vanessa? I need it as a coordinate. Pardon? Yeah, this is my vertex here. So my vertex occurs right where that change comes, and it's 0, 0. So I write that here, 0, 0. The axis of symmetry. You guys have pencil crayons? Might be useful to maybe color code it. You're more than welcome to. The axis of symmetry is where, again, where does it split in half? Where is it perfectly symmetrical? Your axis of symmetry here is this green line. That's where it cuts it in half. That's my axis of symmetry. So I'm going to write that in green here. And I will always describe it x equals, and then it's just simply the x coordinate of the vertex. Or where does it cross the x-axis? It crosses the x-axis at 0, so I write x is equal to 0. Any questions with what I've done so far? Direction of opening, that's a pretty straightforward. Vertex, hoping is straightforward. Axis of symmetry, that might be something new. Okay, now when I talk about the domain and range, this is what we practiced 2 days ago. So I'm going to tell you something. Because this graph is continuous, is there a maximum x value that it will have? No. Is there a minimum x value it has? No. You will find that this is true for all parabolas. There's no maximum or minimum x because x goes horizontal. So what I'll do here, the set of x such that x is an element of the real. Now, when I look at the range is a little bit different. Is there a minimum value for the range? A minimum y value. Austin? Yeah, it's 0. I will never use any of these y values down here. So when I write this, again, because it's continuous, it has the arrows, it's always going to be going up. So I'll have here y such that y has to be greater than or equal to 0, where y is an element of the reals. Jenny?
So if it's always, like, let's just say it's always going up, it'll always be x is the element of the real or whatever it is. It's always going to be just that example. Like if it's continuous.
This is continuous on the domain, so it will touch all x values eventually. The graph may be huge, but it will touch all x values, so that's when we say this is what it means, is that it includes all x values, the element of the real. So yes. Okay, now you'll look here, is this a maximum or a minimum? Does this function have a maximum or a minimum? It has a minimum. So I'm going to write here, it has a minimum, and then I use this, y equals 0. Okay, does anyone have any questions about this? This is the basic function that we are going to use forever, or at least for the next 3 days. Okay, going on to the next, we're going to look at transformations. It says in general, all quadratic functions, they have the form f at x equals a bracket x minus h all squared plus k. Today we're going to only look at vertical transformations and how that occurs. So we're going to see what happens if I change my a and my k values to our comparison graph of x squared. The a value, if you don't remember, it controls the shape of the graph by either stretching it or compressing it, making it flatter. Or you can also have it reflecting the graph. So what I'd like you to do is with one color of the pencil crayon, you're going to graph our parent function, x squared, which I've plotted the values down here. So graph that function. So -2, 4. Pardon? That's this one. We're going to have 3 graphs on there. So everyone, plot these points on that grid for me. So this is the same graph that we just plotted. which is y equals x, or I shouldn't say y equals, f at x equals x squared.
F at x means y, you said?
Pardon?
F at x means y?
F at x means y.
So if we write y, it's...
We have to start using function notation. Jenny?
When it is when f at x equals negative x squared, do you and if it's a negative underneath, do you change the sign into two negatives, or do you just leave it as it is?
Okay, we're gonna go through it when we substitute it in, what that will look like. Okay, so when I have here f at x equals negative x squared, how do you put this inside your calculator? When I put this first value inside of it, this is what I would write. F at negative 2 equals negative, and then put in brackets negative 2 all squared. You have to use brackets there. Type that into your calculator and see what do you get. You get negative 4. What about negative 1? What do I get? I'm going to go around the U. You're going to tell me what you get. Jericho, what do you get when you at f at negative 1? Very good. Zach, f at 0?
0.
Then what do you get f at positive 1?
1.
What do you plug it in?
Um, 2.
Not 2, negative 1. If you did negative and then bracket negative 1 squared,
Wait, why would you do a negative 1 squared in the bracket?
Negative 1.
pardon?
I said, would you, like, negative bracket negative 1, but aren't we doing positive 1?
Yeah, we're doing positive 1. Sorry, did I? But you still get negative 1 as an answer. Does that, Ben, did you know how to put that in your calculator?
No. But if you want to be fancy, you can go like that. And or positive 1.
Okay, Kev, what do I get when I f at 2?
-4s.
Negative 4. So in a different color, I'm going to plot this. So when x is negative 2, I have negative 4.
What would you see different color?
Okay, so what happens when there's a negative sign out in front of that x squared? How does this graph, my green graph, compare to my blue graph? What words would you use to describe that? Anyone? Shocking. Nick, just don't do it. Just don't do it. Okay, we say that that's reflected on the x-axis, so that's like saying it's flipped. So when it's negative, instead of opening up, it opens down. What's my vertex here, Austin?
8.
Pardon? My vertex?
Sorry, I thought we were doing the other box thing. Vertex is 0, 0.
My vertex is 0, 0. The axis of symmetry. Robbie, what will I say for the axis of symmetry?
Y equals 0. Or x equals 0.
X equals 0. That's where it splits it in half. So again, my axis of symmetry is this line right here. It will go up and down like that. That's the axis of symmetry. My domain. David, what's my domain here? Yeah, it's an element of all real numbers. Okay, Nick, this one's a little bit tricky. My range. Does it have a maximum or a minimum here?
Maximum.
Why does it have a maximum, not a minimum?
Probably said.
Well, if you look at the graph, it's continuous this way.
Sorry, say it again. It's continuous.
So because it's green, right, it's going down like this. Do I have the highest point? Do I know what the highest point is?
Yeah.
What is it?
0.
Yeah, so that's the maximum. So I'm going to start here. So this is my maximum at y equals 0. Because it has a maximum, that means when I write my domain, or sorry, my range, y, such that y has to be less than or equal to 0, where y is an element of the reals.
How come we're going down again and not up? Well, like how? No, I know why we're going down, but how come there's an up graph? Or graph over there?
We're comparing it to this function here.
Oh, okay, so it doesn't.
So everything that we're going to talk about is always in relation to this blue graph. Okay? So this green graph, how did this green graph change from this blue graph? That's what we're going to be talking about. That's our comparison. Okay? Okay. The next one, Danny Ram. When I have x is negative 2, what does f at x equal here? Pardon? 8. Nathan, what's f at negative 1?
4.
No.
2.
It's 2, so negative 1 squared times 2 gives me positive 2. Caitlin, what do I get? F at 0, what do I get?
0.
Good. Yulia, f at 1, what do I get?
2.
Good. And Vanessa, f at 2, what do I get?
8.
Good. So again, in a different color, can you please plot that graph? Okay, Jenny, what's the direction of this new graph?
Up.
Good. What's my vertex, Danielle?
0.
Good. The axis of symmetry, Carissa, what is that?
0, 0. I mean, x equals 0.
Perfect. Laura, what's my domain here? It's the same for all of these because it will hit all x values.
Same as the other ones.
Yeah, so I will have
Minimum 0.
pardon?
So always 0.
Jericho, what is the range here? Hello? Yes, he is. Yes? Okay. Detentions after school. Okay, what's my greater than or equal to? So if it has, okay, does this have a maximum or a minimum, Jericho? So it has a minimum at what? Y equals 0. So if it's a minimum at y equals 0, then for my range here, I'm going to put y has to be greater than or equal to 0, where y is an element of real numbers. You may want to jot this down somewhere off to the sides. If you have a minimum, you will always write your range. Y has to be greater than or equal to whatever your minimum is. If you have a maximum, your range will always be set up like that. You may want to jot that down to help remind you. This little piece right here, somewhere on there, as a good clue to help figure out your range. Jenny?
Does it matter if it's up or down that the min or max would be?
Absolutely.
Yeah.
You have to look at the graph and tell me, does it have a minimum value or a maximum value?
Okay.
And if it has a maximum, your range will be in this form. If it has a minimum, it will be in this form. Okay, we're going to do another one here. This, instead of, I know it's in a fraction, how else could I write 1/2? 0.5. So I'm just going to rechange this. F at x equals 0.5 x squared. Again, on this new page here, I'm going to still graph this equation here, my parent equation. My y equals x squared. So okay, Zach, f at -2, what do I get here? When f at x equals 1/2 x squared, I get 1. Ben, what do I get when f at -1? What would you put in your calculator for that?
You get a 0.5.
Yep.
You put 1.
What do we get?
Oh,
-2.
2, 4, it's 2, positive 2. Sorry, guys. -2 squared gives you 4. Half of 4 is 2. Ben's still good because f at -1, so -1 squared gives you 1. Half of 1 is 0.5. Kevin, what do I get? F at 0. Pardon? 0? Austin? F at 1. Robbie, f at 2 is 2. So let's plot that graph. Okay, visually, what happened to the graph? When I had 0.5 out front, what happened to that graph? How could you visually describe what happened from blue to green? Robbie? It was compressed, which means you're pushing it down, which means it gets wider. Stretching would be that it gets skinnier. Compressing means it gets fatter, if you wanted to call it like that. This one here, if you look from the red to the blue, so red was a 2. So if I took my blue, I stretched it, I pulled it in order to get the red. Okay, doing this information here. David, what is the direction of the opening here? It is? What's my vertex, Nick? Good. Axis of symmetry, Nick? Pardon? That's not how I write it. X equals 0. Good. Nathan, my domain. Good. Okay, what would my range here be, Caitlin? Good. So looking at this graph, this definitely has a minimum. So if I have a minimum, I know my range is going to be set up there with my minimum value in there, which is 0. So I know my minimum occurs at y equals 0. Any questions about this? Jenny? Okay, look at the graph. Minimum means the lowest value. Do you know what the lowest value is in the graph? Yeah. Do you know what the highest value is in that graph? That's why it has a minimum. So it will have one or the other. If we look at this graph here, in this green graph here, does that green graph have a minimum? Does it have a lowest value? The arrows are going down like this. So the lower the number, the lower it goes. So this is going down. So it will never go up. So it has a maximum value of 0, which is when we do it like this. Yep. Yep. Okay, going on, Yulia. F at -2. What do I get here? So this again would be like f at x is equal to negative 0.5 x squared. What do I get here? Very good. Vanessa, what do you get when f at -1? Very good. Jenny, f at 0? Danielle, f at 1? Good. Carissa, f at 2? Pardon? He's teaching computer science. 243? Yep. Okay, and then if we plot that, what will that look like? So I have -2, -2, -1, -0.5, 0, 0. Oops. Okay, so what's my direction of opening, Laura? Good. My vertex. Jericho? Pardon? 0, 0. Axis of symmetry, Zach? Good? Ben, what's my domain here? Does it have a minimum x value?
Yeah. Oh wait, sorry, it's maximum.
You're thinking range. X is going like this, which means that it will eventually hit everything. So we have here x such that x is an element of the real. It hits all real ones. The domain's easy for this unit. It will always be element of the real. Kev, what's my range here? Do I have a maximum or minimum? So when I have a maximum, I say y has to be less than or equal to what number? 0, where y is an element of the reals. And we know that it has a maximum at y equals 0. Okay, does anyone have any questions about this? Nick? Pardon? This is
Why do you use it? Why do you use less than and greater than? Why do you use greater than y?
because it will never be lower than this. So it will always be bigger than your lowest value. So it will always be greater than 0, because 0 is your lowest value. It will continue to go up. Jenny?
Will it always be or x of the real or whatever it is if it comes at 0?
Will it hit all x values? It's continuous. It's constantly going out like this.
Okay.
Yes.
When will it not?
So I think I've said it 3 times. For parabolas, it's easy because your domain is always an element of the real. Okay? Parabolas will always be element of the real because it's continuous and it's constantly moving to the left and right. It will cover every x value. It will just take forever to get there. Okay. The next one we're going to deal with is our k value. So we saw how there's stretching and then there was compressing. So I had making skinnier, making fatter, and then I had some that were flipped. K is the number on the outside here. So A was attached to X. K is being added. So again, I'm going to figure out, I'm going to plot my parent function here. Okay, going on. Austin, what is f at negative 2 here?
What is that? X squared plus 3?
Yep.
Like 7?
Robbie, what's f at negative 1?
4.
David, f at 0.
3.
Nick, what's f at 1 here?
4.
Other Nick, f at 2. 7. So I'm going to plot that out. Does anyone not know how I'm getting my equations or those numbers in the table of values? Pardon?
What number are you using?
For this, I'm using this equation.
What are you putting in the x?
Negative 2, negative 1, 0, 1, 2. So if I plot that negative 2, 7, 1, 2, 3, 4, 5, 6, 7 is here. Negative 1, 4, 1, 2, 3, 4 is here. 0, 3 is here. What happened to this graph? What happened from blue to green?
Oh, it moved up.
How much?
3 spaces.
It moved up 3 spaces. Every point here moved up 3 spaces. That 3 came from this plus 3 here. So Nathan, what's my direction of opening?
Up.
What's my vertex? Caitlin?
Um, 3 0.
Close.
2.
0, 3. So again, x is still 0, y is 3. The axis of symmetry. Yulia, what's my axis of symmetry here?
0.
Yeah, x equals 0. My domain. Vanessa, what's my domain here?
X, equals 0.
Very good. Okay, Jenny, do I have a maximum or a minimum?
A minimum
Good. Where does that minimum occur?
at 0. Or
Will green ever touch 0 here?
no, it won't.
So I have a minimum at y equals 3. So tell me what the range is, Jenny.
It's line
Such that?
such that y will be greater than or equal to 3x. Yeah.
Good. Any questions with that? Yulia?
Does the parabola always have to be symmetrical?
A parabola will always be symmetrical.
No.
Okay. Danielle, going to my next one here. I now have x squared minus 4. So what will I get here? When negative 2 squared gives me 4, 4 minus 4 absolutely gives me 0. Carissa, f at negative 1, what do I get there?
So
So sub negative 1 in for x. What do- negative 1 squared gives me 1. So 1 minus 4 gives me negative 3. Good. Laura, f at 0, what do I get?
-4.
Jericho, f at 1, what do I get? Zach, f at 2, what do I get? Good. Direction of opening. Ben, how does, oh, wait, let's graph it. Ben, how does that graph open?
Up.
Good. What's my vertex, Kev?
Zero, 4.
Not 0, 4. 0, negative 4. Very good. My axis of symmetry, Austin, what is it?
The axis of symmetry is still x equals 2.
Good. My domain, Robbie?
X, right here. Oh, I wrote it twice.
Good. Uh, David, does this have a maximum or a minimum?
Minimum.
Good. Where does the minimum occur?
-4.
Good. Minimum at y equals negative 4. So, Nick, tell me what the range is. Pardon?
Okay, y, that line, the y, I don't know which is less than.
Which one do I use?
It's minimum, that one.
So I say greater than
Oh, greater than
or equal to.
-3. Same. No. -4.
Or y is an element of the real. My minimum was at -4. That's why I put -4 in the range. Okay? So if you look here, I had one graph where x squared said +3. The graph shifted up 3 units. This equation here, x squared -4, the graph shifted down 4 units. So I had one that made one skinny, one fat, and then moved it up and moved it down. Okay, so anyone still copying this? Now we're going to look at A and the K. So we're combining both of these steps together, and then we are done. So if I substitute this into my calculator, I would write -2. I'm going to write this out for you just in case you don't know. -2 bracket -2 squared plus 3. That's what you would type in your calculator for the first one. And then you're just changing these values in between. Yes.
Did you do -2 times -2 first, or did you do the -2 entire?
Okay, you're going to put it in your calculator, the whole thing in your calculator, and it will do it. But
So I
speaking of bed mass, you do exponents first. So -2 squared would come first. Okay, Nick Daniel, what do you get here? -2 squared gives me 4. 4 times -2 gives me 8. Very good. Nathan, f at -1, what do I get? Good? Caitlin, what do I get for f at 0? Not 0. -2 times 0 squared plus 3. If you put that in your calculator, you get 3. Then it becomes f at 1. Vanessa, what do I get? Oh, sorry, Yulia? Not 2, 1. And then Vanessa, what do I get at f at 2? -5. So again, plotting this, I'm still going to plot my parent function here, which I forgot to do. That's x squared. So what will f at -2 x squared plus 3 look like? So I go -2, 1, 2, 3, 4, 5. -1, 1, 0, 3. That's what my graph looks like. So right away, when you start seeing the equations, you should say, or you should be able to see, does it open up or down? It has a negative sign, it opens down. Will the graph be skinny or will it be compressed? Stretched or compressed? It's going to be stretched. Will it be shifted up or down? The +3 says it goes up. So my direction of opening here, Danielle, what is my opening? Good? Carissa, what's my vertex here? Perfect. Laura, what's my axis of symmetry? Very good. My domain, Jericho? Is an element of the real because it's all numbers. Good. Zach, do I have a maximum or a minimum here? At what value? I have a maximum at 3. Ben, what will I write for my range here when it's a maximum?
All three.
Pardon?
And,
I look at here, maximum.
sorry, I just don't know this stuff.
Well, it still says y. I'm going to put less than. And then what's my maximum value? Yes? Or y is an element of the real? Good.
Why do you put the 3 in front of the... Oh, I remember.
Okay, going on to the next graph. Again, I have f of x equals x squared minus 4. Kevin, what do I get for that when I plug that into my calculator? Negative 2 squared gives me 4. 4 times 2 gives me 8. 8 minus 4 gives me 4. Austin,
Yeah.
f at negative 1, what do I get?
3, 1.
F at 0, Robbie, what do I get? Yes.
How is first y 1?
Negative 2 squared gives me 4, right? 4 times 2 gives me 8. 8 minus 4 gives me 4. Okay, my next values will be negative 2 and 4. So when I graph this, okay, direction of opening. David, what is it?
Going up.
What's my vertex here? Nick? Green? Good. My axis of symmetry, Nick? Good. My domain, Nick, or Nathan? Good. Caitlin, what's my range here?
This y plus such that y greater than negative 1.
Good. And then is there a maximum or minimum, Yulia?
Minimum y equals negative 1.
Good. Okay, that's parabolas, vertical transformations in a nutshell. The last page here is just talking about a description. So for communication marks, you should be able to look at a graph and see what will happen or be able to predict what happened. Hello? Yes. Yes. Yep. Jericho and Kevin, go down to student services, please.
What?
Okay. So, as kind of a summary, we're just going to go over this last part here. Can you describe the shape and position from just looking at the quadratic? When describing A, so A is the number in front of x squared, that multiplying 1. Use words like compressed. It will be compressed if there is a decimal or a fraction. In other words, not always a decimal or a fraction, typically. Or we say that it has to be less than 1. got to be less than 1. So if it's 0.5, 0.75, but if you had 1.5, that's greater than 1. We say it's stretched if it's greater than 1. We say it's reflected when it's negative. Okay, so that's it in a nutshell. When describing K, use phrases like a vertical shift up. We know that is when it's positive. Or a vertical shift down when it is negative. So as an example of how you would describe this one without graphing it, 0.85, that is less than 1. So I say compressed. I'm just going to say compressed. No, I'm not. Compressed by a factor of 0.85. Okay, because that decimal out in front is, it's less than 1. It will open up because this is a positive number. And there will be a vertical shift of 4. A vertical shift up of 4.
So if the last number is positive,
There will be a vertical shift up. The last number is negative. It will be a vertical shift down. Looking at this one, what could you tell me about this equation here? F at x equals negative 2x squared minus 12. Austin?
Reflected by a factor.
Reflected by a factor. Oh, hang on. This is a two-part. Okay, it's reflected in the x-axis. We're just saying it's flipped. Okay, now this 2, will it have a stretch factor or a compressed factor? Will it be stretched or compressed? Yes, it will be stretched by a factor of 2. Will I have a vertical shift up or a vertical shift down? Just 12. Because you're saying down, you don't need to put negative. That implies it. Okay, so this is how you would describe it. Again, you're looking at those key values. I'm going to give you a worksheet